All right, we're going to talk about writing equations in slope-intercept form. So first of all, what is slope-intercept form? So if you recall, when you are writing it in slope-intercept form, it is in the form y equals mx plus b, where m is the slope, b is your y-intercept. So basically when we're doing the slope-intercept form, we are solving for a y. Okay? So if you recall from Unit 1, when we were doing the literal equations, we had more than one variable in an equation, and we were solving for a particular variable. This was preparing you for this. So here we need to get y by itself, so I need to move x. So I'm going to subtract x from both sides. That leaves me negative 2y equals negative x plus 2. Divide by negative 2. I get y equals, what's understood here? A negative 1. So negative 1 and negative 2 makes a positive 1/2 x. And then positive 2 divided by negative 2 is negative 1. Okay, so that is our slopes 1/2. Our b is negative 1. Okay, so you may want to stop the video here and go ahead and try to do b, c, and d by yourself, and then come back and check your answer. Okay, so here we're going to subtract 6x from both sides. That's going to give me 3y equals negative 6x plus 21. Divide by 3. So y, negative 6 divided by 3 is negative 2x. 21 divided by 3 is plus 7. So reach out if you're not getting these and you're not understanding. So here I need to move the 3x. So I get negative 4y equals negative 3x plus 16. Divide by negative 4. So y equals negative divided by negative is positive 3 over 4x. And then 16 divided by negative 4 is minus 4. Okay, the last one, we just need to move the 2x. So we would subtract it, and we get y equals negative 2x plus 8. So slope-intercept form, there we have solving for y. Okay, so the next step, write equations in slope-intercept form given information. Okay, so here we're going to find the equation of a line that has a slope of 4 and passes through this point. Excuse me, so if we were to look at the graph would have a slope of 4, and the line, the linear function, would go through the point negative 4, negative 3. So again, if we use the y equals mx plus b, we know our m is 4, and we don't know b because this does not have b, because anytime we know the y-intercept, we know x is 0. So this is not the y-intercept. So what is this? Well, this is x, and this is y. So I can plug in what I know. I know x is negative 4, y is negative 3. So negative 3 in place of y, and negative 4 in place of x. And now I have one unknown, so I can solve for b. So that's going to give me negative 3 equals negative 16 plus b. I'm going to add 16 to both sides. So 16 plus negative 3 gives me 13, and that's going to equal my b. Now, was the whole goal of this problem to solve for b? No, we want to find the equation. So y equals 4x from the slope plus 13. All right, find the equation of a line that passes through and has a slope of 4. So y equals 4x. We don't know b again because x is not 0, but we do know x and y. So I plug x in and y. So I have negative 1 equals 4 times negative 4 plus b. So negative 1 equals negative 16 plus b. I add 16 to both sides. Negative 1 plus 16 gives me 15 equals b. So y equals 4x plus 15. If you remember from yesterday, these two have the same slope, so they would be parallel lines. Okay, find the equation of the line shown below. So a lot of times when we have the graph, like here, we know the y-intercept. It's 2. So we already know that we can put plus 2. And now we need to find the slope. So I'm just going to use this point. You could use any point as long as there were points there. So that's going to be 6 and 2. All right, so 6 and 2. So 6 divided by 2 is 3 because it's rise over run. It slants to the right, so it's positive 3. So y equals 3x plus 2. Okay, on this one, our y-intercept's here at 4. And then if we want to find our slope, there's a point here, so we can go down and over 1, 2, 3, 1, 2. So that's going to be 3 halves, rise over run. But this slants to the left, so we're going to need to put a negative to show the negative direction of the line. Okay, so we're going to look at that. Now we're going to graph linear functions using that data that we just found. So when graphing linear equations or inequalities, the function must be written in slope-intercept form. Slope-intercept form. Okay, and we just talked about that. That's y equals mx plus b. Okay, so here we're going to solve for y. We're going to subtract 6x from both sides. We get 3y equals negative 6x plus 9. We're going to divide all the terms by 3. So that will give me y. Negative 6 divided by 3 is negative 2x. And then 9 divided by 3 is 3. All right, so here is the slope-intercept form. This tells me my slope and my intercept. So I know from here that my slope is going to be negative 2. That tells me my line should slant to the left. And my y-intercept is 3. So that would be the ordered pair 0, 3. This is our starting point. This is where we always start with. So 0, 1, 2, 3. Our slope's negative 2, so that could be negative 2 over 1. Or it could be positive 2 over negative 1. So we could go down and right or up and left. So if I go down and right, down 2, right 1, down 2, right 1, or I could have went up 2 and left. Notice that line slants to the left, okay? And then we will just connect those dots, try to use a straight edge, and then an arrow showing that they go on forever and ever. Okay, just real quickly, if you have y equals 2, there's no slope here, but you have a y-intercept at 2. 1, 2. And then, if we think about this, if we were to try to make one of our tables, y is always 2. X could be negative 2, it could be negative 1, it could be 0, it could be 1. So at negative 2, y is still 2. At negative 1, y is still 2. At 1, y is still 2. So what do you notice here? It's making a horizontal line. So exactly, at y equals 2. So then, if you have x equals 3, x is 3, 3, 3, 3. Y could be negative 2, a negative 1, 0, 1. So, at 3, 1, 2, 3, negative 2, 3, negative 1, 3, 0, 3, 1. What kind of line is this making? Exactly, a vertical line. So those are special cases lines that you should know. We talked about the other day, horizontal line, 0 slope, vertical, undefined. Okay, so let's do 2 more examples here. So we're going to solve for y. So we're going to subtract 4x, So I get negative 3y equals negative 4x plus 6. Divide by negative 3. So I get y equals negative I by negative is a positive 4/3 x. 6 divided by negative 3 is a negative 2. Alright, so here my slope is 4/3. And my y-intercept is 0, negative 2. So that's my starting point. 4/3, 1, 2, 3, 4 up. And then 3 is positive, 1, 2, 3 to the right. I couldn't go down 4 on this graph, so that's my only 2 points, and you only need 2 points to make a straight line. Let's see if I can connect them. Yay! Alright, again, I would use a straight edge if I had one for this. It helps you. So there is your line that represents this equation. Alright, here we're going to solve for y. We're going to add 4x to both sides. And notice there is an x over here. So we're just going to combine like terms. We're going to get negative y equals 6x minus 2. I need to solve for y, not negative y. So I'm going to divide by negative 1. So y equals negative 6x plus 2. In this case, my slope is negative 6. So my line's going to slant to the left. My b is 0, 2. 1, 2, 3, 4, 5, 6. And then I need to go right 1. Okay, we're going to connect those dots, and this is going to be a steep line. And then we're going to do our arrows. All right, guys, so what have we talked about today? We are going to put our equation into slope-intercept form, y equals mx plus b. M's our slope, b's our y-intercept, and then we're going to use those to graph and be able to go from solving for y, writing the equation, given the slope and a point, and then given the graph. Please check plan book and reach out if you have questions.